Hi everyone, welcome back. In this video, we're going to take a look at the law of cosines, so helping us solve triangles that aren't right triangles or oblique triangles. We're also going to look at finding the area of a triangle when we're not given the height. So to start off, we're looking at law of cosines. Law of cosines, in this video, we're just going to look specifically at side angle side triangles. So like the triangle down here to the right, we have, oops, and I'll move that up a little bit. We have two side lengths, 2 and 3, and then the angle in between 60 degrees. There are other situations where we can use law of cosines, and in fact, law of sines. We'll talk about that later in another unit when we look at the inverse trig function. So later on, today we're just looking at finding a missing side length when we're given two sides and the angle in between them. So here, in situations like this down here, we can't use the law of sines because we end up, no matter what equation we set up with law of sines, we end up with two unknown variables. So we can't just solve for the single unknown variable. What that means is we will have to use another method or another formula. In this case, we're going to be using law of cosines, which I've written down over here. We have our unknown side c. We take c squared and set it equal to the other two sides squared, the sum of the other two sides squared, a squared plus b squared, and then subtract 2 times a times b times the cosine of gamma. And gamma is the angle opposite of the unknown side that we're looking for. If we look at this generic triangle on the right, if we're trying to find c, gamma is the angle opposite of c. In other words, it's the angle in between the other two side lengths that we're working with, in between a and b. You might notice that this looks similar to the Pythagorean theorem, c squared equals a squared plus b squared, and that's because if we have a right triangle and our opposite angle is 90, cosine of 90 actually becomes 0. So this entire term just becomes 0. So for right triangles, the law of cosines is the Pythagorean theorem. We're interested in not right triangles, though. We're interested in oblique triangles and how we can use this to solve for oblique triangles. So let's take a look at the example I have to the right here. We have two side lengths, 2 and 3, and then an angle of 60 degrees in between them. So our unknown side length is c squared equals, and then it doesn't matter which one we assign as a or b, 2 squared plus 3 squared minus 2 times 3 times cosine of, in this case, gamma. The angle in between them is 60 degrees. And then we just simplify. So 4 plus 9 minus 2 times 2 is 4 times 3 is 12 times cosine of 60 degrees. So here we get c squared is equal to 13 minus, if we plug in cosine of 60 degrees in our calculator, we actually get 1/2. So we just have 12 times 1/2, which is 6. In other words, c squared equals 7. So finally, c is going to be equal to the square root of 7. Note, I'm only taking the positive square root, and that's because c is a side length or a distance, so it can't be measured as a negative value. So just the positive square root of 7, and that is our final answer for c. So using the law of cosines to solve for an unknown side, using the other two side lengths, and then the angle in between those side lengths. Any word problems that were given for this unit can be broken up or written as a triangle similar to the one that I wrote in this example. Okay, next up, we have the area of a triangle. So we've worked with the area of a triangle quite a bit over the past few years, especially in geometry. The formula, as we all should know, is a equals 1/2 times the base times the height. So the area of the triangle is 1/2 times the base times the height of the triangle. If we're given the base and the height, we just plug them in, and then we're done. The issue that we're facing now is we're not always going to be given the height of a triangle. So for example, down here we have a triangle, and instead of the height of the triangle, we're just given the two side lengths, 5 and 3, and then the angle in between, 40 degrees. And we're being asked to find the area of this triangle. So in this case, it's a little bit more complicated. What we can do is split this up into right triangles. So this is our height here. I just drew in the height, and then we end up with a right triangle, which allows us to use right triangle trigonometry to find the area. We're going to do that for just like a generic general triangle, see what equation we come up with, and then we can use that equation anytime we encounter a triangle where we're given a side, an angle, and a side, and being asked to find the area. So if you forget this formula ever, you can go through this process of splitting it up into right triangles and then thinking it through from there. The equation is just going to be going through that process and then finding a quick equation we can use anytime. So here we're given a triangle. As you can see, it's not a right triangle. And we're given two side lengths, A and B. And then we're given this angle over here, gamma. So this other angle in between those two side lengths. So what we can do is draw in the height. So here we have the height. The height is going to be perpendicular to this bottom side, B. And that means that, notice we have a right triangle here. We've now drawn in a right triangle. And what that does is it allows us to, using right triangle trigonometry, write the height in terms of two things we know, the side length A and the angle gamma. So here we can use right triangle trigonometry. We know that sine of gamma is going to be the opposite side, so H, over the hypotenuse, which is A. And we can quickly rewrite this. The height of the triangle is equal to A times the sine of gamma. So we don't know the height, but we do know A, we do know gamma, so we can use those values to quickly find the area. And I'm going to write that out really quickly. Area is equal to 1/2 base times height. We don't know the height, but we can replace that with A times sine gamma. And then our book just puts A in front, so 1/2 A times B times the sine of gamma. So if the only information we're given is these two side lengths, A and B, and the angle in between, gamma, we can use this equation to help us quickly find the area, just plugging in those values and then simplifying from there. Okay, and this gamma is always going to be in between, so the angle in between the two sides that we see over here, A and B. So if you're ever confused about what angle to use, it's going to be the angle in between the two sides that we're using. Okay, so let's take a look at this example on the bottom left. Here we're given side length 3 and 5 and an angle in between of 40 degrees. We can use our area equation, 1/2 times the base, which we could set it, it doesn't matter which one we set as A or B, so we'll just do 5 times 3 times sine of 40 degrees. And then we can just use our calculator to simplify. So sine of 40 degrees gives us about 0.642. And then we'll take that multiplied by 3 times 5 times 0.5, and we'll end up with an area of about 4.82 units squared. So keep in mind this is area, so it's going to be units squared if we're solving a word problem, for example. Okay, so just plugging in those values to find the area really quickly. There's one other situation where we'll be asked to find the area without being given the height, and that's when we have 3 side lengths. So here you might notice that we have a triangle with side lengths A, B, and C, and we don't know any of the angles inside. In this case, what we can use is something called Heron's formula, where if we have 3 side lengths, we can use those 3 side lengths to calculate the area quickly using this formula. So to find the area of a triangle with 3 side lengths, A, B, and C, we can use this equation. Area is equal to the square root of S times S minus A times S minus B times S minus C. And S is just a number or a value we can find really quickly first using the 3 side lengths. As you can see down here, S is equal to 1/2 times the sum of all of the side lengths. So we add them all up, divide by 2, and then that's our S value that we'll be plugging in. And then we just plug in A, B, and C, the 3 side lengths in those 3 spots, and then we simplify from there. So finding the area quickly using 3 side lengths. Let's take a look at a quick example. Here we have side lengths 5, 7, and 8. First, let's find out what that S value is equal to. So 1/2 times the sum of all of these side lengths. 1/2 times, in this case, 20. So S is equal to 10. So if we bring out our formula, Heron's formula, we have the square root of 10, S, times S minus A, 10 minus 5, times S minus B, 10 minus 7, times S minus C, 10 minus 8. And it doesn't matter which numbers we assign to A, B, and C. It just means the 3 separate sides. Okay, and then now all we have to do is simplify. So 10 times 10 minus 5 is 5, times 10 minus 7 is 3, times 10 minus 8 is 2. So we end up with the square root of 10 times 30, which gives us the square root of 300. And then if we want to simplify this radical, it would be square root of 3 times 10 squared. So we get the area is equal to 10 root 3 units squared. So the area of this triangle up here, where we're just given 3 side lengths, we can find that quickly by plugging it into Heron's formula, finding S first really quickly, and then end up with our area down here. Okay, so in this video, we went over law of cosines and how we can use law of cosines to quickly find a missing side length if we're given a side, an angle, and a side. We also went over the area of a triangle, how if we're not given the height, we can still find the area of a triangle really quickly using 2 side lengths and the angle in between. We could also find the area of a triangle really quickly using just the 3 side lengths of a triangle. Okay, so that's all we have to cover for this video, looking at law of cosines and then area of a triangle.